Mega Mart store is a CPM problem. Many times in working CPM problems, practicing CPM, we get used to there being some tasks, some precedence information, some duration, and that's it. Mega Mart store here is more realistic in that we actually have the situation, which is good, but it does add an extra layer of complexity to the problem. Let's take a look. Mega Mart store is a discount department store badly in need of renovation. Okay, that's the context. To avoid loss of sales and disruption of customer shopping habits, Mega Mart wants to complete this renovation without closing the store itself by temporarily co-locating goods from one area of the store into another, creating open spaces for renovation and reoccupation. Mega Mart is divided into 4 basic areas. Okay, this is going to become important. Clothing, electronics, housewares, and foodstuffs. Each of these areas need to be temporarily moved as described by the following tasks. Now, let's take a look at this. This is a CPM problem, right? There's a set of tasks and they're abbreviated A through L. That looks pretty familiar to us. There's descriptions because these tasks do represent specific tasks within this project, this renovation project, but then there's the same old precedence relationship and there's the same old task lengths. Oh, now, right away, it starts asking questions. What question are we going to tackle right now? It says, what are the paths through the project network diagram describing Mega Mart's project data? Oh, well, in order to answer that question, we have to draw the network illustration of all of these tasks. Now, if you've downloaded the note frames, there's a blank sheet of paper after this one in which to draw on, and you don't actually need the note frames for that, right? You otherwise are going to want your own sheet of paper to do it. Either way, whether it's a note frame or whether it's your own sheet of paper, it's a quick recommendation for Mega Mart. Turn the paper this way and draw across, because I've already sketched this network and it's kind of, well, long and stringy in a certain sense, and you kind of be glad you did. The reason that I'm saying that right now is you're going to notice me here turn it right side, sort of up, letter format. And it's not because that's the most convenient way to position the paper. It's because of the document camera here. I want to make sure that you can see what I'm doing all the way from left to right. Anyway. Oh, right. Other thoughts about drawing networks, because this one will be kind of complicated. We always draw in pencil if we can, right? We just don't know, we might need to erase. Fine, going to do that. Okay, then let's start on Mega Mart. Let's see, to draw a network, because we need to determine what the paths through that network are, we have to draw the start of the project. And I'm going way over to the left-hand side of my sheet of paper because it's pretty narrow, the space that I'm working in. Oh, I drew a starting node. Good. Now, what do we do next? We review the data. We look for every activity that does not have any immediate predecessors, because that activity would be attached to the starting node. We're used to them kind of sometimes being listed at the top of a task list, but you know, there's no rules. I noticed that A, for instance, doesn't have any immediate predecessors, but down here, about a third of the way down the list, I noticed that D doesn't either. All right, no problem. That means that I want to add A, and D to my network. From the start, you can proceed with either of these. Now, it's not strictly necessary to drawing the network. It's not strictly necessary to answering the questions, how many paths are there through this network? But something about Mega Mart that would be kind of handy later is that the tasks themselves, you notice, I mean, they have meaning. What is A? Co-locate clothing in the electronics area, which means take the clothing and move it to the electronics area. D, co-locate housewares into the foodstuffs area. Take housewares and squeeze it into the foodstuffs areas. I'm going to jot a little note, not in here. We're going to need this for our calculations, but what is A? It says co-locate. I'm just going to write move. It's shorter. Just, it's a note to myself. This right here, this is move the clothing. Okay, move the clothing out of the way of the renovation. Same thing here. This is move housewares. I'm not going to bother to state the destination because it's just a quick note. What is that? That's move the housewares out of the way. Okay, fine. Now, what do we do next? Well, now we start building the network based on what we've already drawn. I'm just looking at the information again, and I notice, okay, B, renovate the old clothing area, has A as an immediate predecessor. That makes sense. Once you've moved the clothing, the actual stock, out of that area, you can proceed with the renovation. So this represents renovate, specifically renovate clothing. Again, this memo note's not strictly necessary. It's kind of handy to helping to understand the diagram. All right, fine. Who's next? Okay, we have B on the network. Oh, I'm looking at C, return clothing to renovated area. Right, when you're done with the renovation of that area, you can then do this. So let's just add that as long as we're working along this path. When you're done renovating that area, move clothing back. That's what I'm going to write because that's what C means. Okay, move it out of the way, renovate, move it back. Fine. What else do we need to do here? Let's see, well, D is already on the network. E, renovate old. Okay, I see a same pattern here. E is renovate the old housewares area, which means you can do that once D is done, and then return the housewares back to the renovated area. That's E. It's essentially the same pattern is up here. It's just different areas, different subjects. So E, renovate housewares, and then F, note to myself, move housewares back. Okay, then what? Let me think. Oh, interesting. Wait, we're down to G on the list. It says G, go the way back up to B. G, co-locate electronics in the clothing area, has B as an immediate predecessor. Okay, well, I can definitely draw that. Now, here's B. What we're saying is that this task called G, so I'm going to stack it up here, can start when B is finished. When we're done renovating the clothing area, G can start. Now, what actually was G? Move electronics. Oh, so this is actually, right here, this is sort of an interesting little fact about the Mega Mart story, if you will. We moved clothing out of its area. We renovated the clothing area. When the clothing area is renovated, that's task B, notice that you can simultaneously, if you want to, this is what the network means, you can simultaneously start moving the clothing back and start moving the electronics out of that area. You can basically evacuate that entire area that was the electronics area, and that's not like any kind of conflict. Nope. Apparently, from what we're told, that would work. That's fine. Okay, G's on the network. Then what? Oh, let's see. Renovate old electronics area has C and G as immediate predecessors. Ah, okay, the electronics area. So that's task H. You can't start renovating that area until you move the clothing back out of that area and you move the electronics out of that area. Then you can start to renovate electronics. Okay. Who else? Oh, okay. Next on the list, 8. Oh, when you're done with H, we just drew H. You can do I, which is, okay, return electronics back to its area. That makes sense. So I will draw that. Move electronics back. Okay. What else do we need to do? J, co-locate foodstuffs in houseware area. Immediate predecessor E. Oh, like we've gone back up the list. Oh, right. This J, K, and L, if you look at it, is the same pattern of precedence relationships as we just drew above. Because it's saying that when you are done with renovating the housewares area, you could move foodstuffs into housewares. See, so it looks similar to up here. And then when you are done moving housewares back where it belongs and moving foodstuffs where it doesn't belong, but temporarily locating it there, that is when you can start the renovation of the foodstuff area. K, renovate. Just making a little note to myself. And then finally, on that list, one last item. L has K as an immediate predecessor. Right, what is that? When you're done renovating the foodstuff area, you can move the foodstuffs back. Phew, there. Then we're done with the list. Oh, we're done with the list, but we're not done with the network, because just as every network has a starting node, every network needs a finishing node. So I just barely, since I was working across the page narrow-wise, have room to squeeze that in. There's the finish. I want to attach every task that has arrows pointing at it, but no way to leave it to the finishing node. And I see, right, you work your way out to I, but you can't go any further. That means it's right at the finish, and here you can get out until you get to L. Then there's nowhere to go. That means that is also at the finish. We have drawn the network. We've drawn the network, and we've invested a considerable amount of time in that, so that we might have forgotten what was it that was actually the question. The question we were working on is, what are the paths through a project network diagram? This is the project network diagram. Oh, paths. We get so absorbed in finding the critical path in CPM that we often forget that there are a bunch of paths through a network. A path is any logical, complete route from start to finish. This particular network, I see 4 of them. Because from start, you could go up to A, and from A to B, and then you could go GHI or CHI. That's 2 paths here, and then see how we have a similar pattern of 2 paths here? Okay, so to formally answer the questions, we do need to actually name those paths. Well, what was I saying? You can go from A to B to G to H to I. That's a path, right? That particular path is the high road across the top. Or A to B to C to H to I, right? That's kind of its twin. Or D, E, F, K, L, or its twin, D, E, J, K, L. And at that point, we have finally found the 4 paths through this particular network.